All right, so welcome everyone. I'm going to present new updates in lockc project. To give you a little bit context, lockc is kind of supposed to be like kind of Cilium, but for security policies. So it's using BPF programs to enforce security rules on containers. And it consists of two parts. One part is a set of BPF programs which runs in the kernel and enforces policies. And there is a user space infrastructure which is taking care of applying the policies, recognizing which container which should have which policy applied, and with communication with Kubernetes. And what's new, the most important feature which was done last 2 weeks are mount policies. The other thing which we have right now is Terraform OpenStack environment. So now to develop lockc, you can use both libvirt and OpenStack for creating your Kubernetes environment on which you want to test. And planned next is hiding unnecessary kernel file systems and creating a lockc Kubernetes agent, which I will explain later what's its purpose. Let's start with diving into mount policies. So mount policies are based on SB mount LSM hook, which is a hook in the kernel which gets triggered every time when we want to mount some file system. And information provided by that LSM hook are the device name, which in case of bind mounts which happen in container host mounts is the source path. There is a destination path which is hashable, and it's not a string but more sophisticated struct which contains unique hash. There is a type of mount, and as we are applying a policy about host mounts in the containers, we are interested on pretty much only in bind mounts. And there are flags and file system specific metadata. And the current implementation looks like on this picture. So in the user space part in lockcd, there is a configurable list of directories which can be allowed for baseline and restricted containers. Those configured allowed prefixes are then saved in BPF map. And afterwards, when we run any container by any container engine, which then ends up being spawned by runc, there is a BPF program controlling all mount operations in the kernel. And based on the information in the BPF map, it decides whether the given mount based on the source path is allowed. So it's pretty much checking whether any prefix matches, so whether any parent of the given directory which we want to mount is allowed. And so far, it's based mostly on string matching. That's because of the one inconvenient thing here. We are checking the only source of information about the source directory which we mount from is the dev name, which is a string. I really wish it was a struct like that's destination one, but it isn't. And yeah, string operations in BPF are very tricky. Like BPF has a limit of instructions and it doesn't contain any string related functions. So you need to implement even functions like strlen, strcmp by yourself. And you need to take care that you don't reach the limit of 1 million instructions while doing any stuff. and you need to take care about how much memory you allocate because it's also limited. I really wish we could receive source path as the path struct. And my idea so far is maybe to try to have some BPF helper which would convert that string to the struct path or struct the entry with the unique hash, and all the task about like parsing that string and generating that struct would happen in some separate kernel thread, not in our BPF program. So yeah, I would like to unload our BPF programs and make them more optimal. But yeah, that's the idea which I'm considering right now for that. And I can show you a little demo about how the whole functionality works. Here I have the website, a small MDBook site about lockc. The address is Rancher Sandbox github.io lockc. And here I will be uploading every future demo. So far we have that mount policies on Kubernetes demo. So let's check this out. So here we are using the Terraform libvirt environment, and we have all-in-one kind of cluster. And we will check right now whether Kubernetes is working and whether any pods are running there. But first, we'll also run bpf2 proc trace in the other terminal to see the logs coming from BPF programs. And we can already see that all the kubeadm Kubernetes pods are running, and on the right side we have a bunch of logs from BPF programs investigating them. And now we'll create namespaces with policies. And we'll have several kind of namespaces. We'll have restricted namespace in which we apply the restricted policy. We have a baseline one on which we apply baseline policy, and we have privileged one on which we apply privileged policy. And by default, in the default namespace, we apply baseline policy, and in kube system, we apply privileged policy. And now we deployed a bunch of deployments which should not fail, which should deploy successfully because none of them is violating any policy. So we have, the Nginx baseline deployment is, for example, mounting stuff only from var data. The restricted containers are not mounting anything from the host, and the privileged one are able to mount anything. And we could also see on the right side that we had a log of BPF program which was deciding whether some particular mount is allowed or not. But now let's deploy also some deployments which should fail because they violate the policies. So we have, for example, that Nginx restricted deployment right now, the new one, Nginx restricted fail, which is trying to do host mount, and we have the BPF fail containers, which deployments which are trying to mount sysfs BPF in unprivileged context. And we can see that all the deployments which were expected to fail, they are failing. So that's it about this demo. And going back to the presentation, Yeah, one of the things on which Michał Jura works, because he loves OpenStack and he wasn't happy about developing lockc locally, he came up with Terraform files for OpenStack. It's pretty straightforward to use. You just build the base QCO image with guestfs with our script leveraging guestfs, and then you apply. Then you create OpenStack VMs with Terraform. And next plans for lockc for next weeks will be hiding several kernel file systems from inside containers, because there are some file systems and some directories which expose, in our opinion, too much information from the host, but they are not namespace. And big example is like for example procsys IRQ or sysfs btrfs, where you, or even almost every file system from the host exposes its sysfs to every container, even if it's not privileged, and you can look up for what partitions are there on host. In case of btrfs, you can even look for RAID 1 policy which is used. There's a lot of information which is not really necessary, which is not namespaced, but since we have all the control about file system interactions, we can hide them on the lockc level with BPF programs. We don't need to push for namespacing stuff in the upstream kernel anymore. So that's convenient. The other feature which we'll work on in lockc will be lockc Kubernetes agent. As you notice on the demo was made on all-in-one cluster, so there were no separate workers. And the reason is that currently lockc runs the wrapper, so the component which wraps every runs the process is communicating with Kubernetes to ask about namespace labels and to decide which policy to apply. And unfortunately for now, we are just using the admin conf from host, which is not on workers. And I know it was pretty ugly solution, but we were kind of on rush to check out the functionality of applying policies and so on. But now we would like to do it properly, and we would like to have a daemon set agent which has airbag policy, which would allow to only get namespace data, and then that agent would expose some small API over Unix socket for lockc to ask about for the given container which Kubernetes policy to apply.